Okay, we're going to introduce mixed numbers and improper fractions, and to do that we're going to use the models, because that'll make the most sense to students. Concrete objects always make much more sense than doing everything in the abstract. So we might begin with the models, and in this case I might have the students show me 2/4, so I might have this on the a camera so everyone could see it. And I'd say there's 2/4, and of course we write that 2/4, no big deal, because here we are in 4th, 5th grade. And if I add another 4th, 3/4, and if I add another 4th, students probably say, oh, you have a whole. Well, that's true, I do have a whole. I do have one. But looking at the way I'm writing it here, and that's sort of why I started at 2/4. By starting at 2/4 and 3/4, if I continue this way of writing the problems, how would I write this one here? And so 2/4, 3/4, it looks like 4/4. Okay, so there's really two ways I can write this representation. 4/4 or 1. And of course in math language you could ask the students, how do we indicate that these two things are the same amount, the same value? We use the equal sign. So continuing in this vein, we go at another 4th. I'd say, okay, let's continue with what we have here. So we have 4/4. What would this be? Okay, it'd be 5/4. 5/4. Okay, but if I look at it from this way, we have a whole and a 4th, which we're going to write as 1 and 1/4. And of course, since these values are the same, they're equal. Here we've got the introduction of an improper fraction, where the numerator is greater than the denominator. So the students, they understand what we're talking about here. Now they're ready for the term improper fraction. They're also now ready for the term mixed number. That we're mixing two types of representations here. We're mixing whole number representations with fractions. We're mixing them both together, so we call it a mixed number. Okay? And we're representing how they equate. Okay, so if I add another 4th, we'd have 6/4, or 1 2/4. And add another one, or a whole and 3/4, and another one. Okay, and so there we've got 8/4, or in this case 2. And of course I can add another one, and so in this line looks like we have 9/4, 9 of these 4th size pieces, or we have 2 wholes and a 4th. And I could continue to do this. Alright, so I've introduced the concept here. I'm probably not going to want to just end with just doing 4ths. I'd want to do another type of fraction, so maybe I'd go through do the same type of deal with the 3rd size pieces, or any other size pieces. Okay, going with 1/3 and writing it down 2/3, writing it down 3/3, having 3/3 equals 1 whole, and so on. Helps them to kind of generalize the concept. It doesn't just work for 4ths, it works for all fractions. So that'd be the purpose of doing more than just the single, using just the 4ths. Okay, now we come to the part where we want to, maybe students have worked on this for a little while, and now we want to be able to convert from a mixed number to an improper fraction, or an improper fraction to a mixed number. How are we going to do that? Well, again, we want the students to tell us, or at least to come up with the ideas, which means we're going to have to use either manipulatives, which they understand, that's always their language, or semi-concrete, where we use drawings, and we might use some drawings here too. Like for example, we might begin with, let's just begin with the 3rd size pieces. And I'm going to go with semi-concrete model, so I can make the thing use a little bit more than all these pieces here, because I'm going to want to do something like 4 1/3. So in this case, I could have the students, show me what 4 1/3 looks like. Okay, so that'd be 4 wholes and then a 1/3. Okay, and if I said I wanted these to be all 3rd size pieces, okay, I only have 1/3 size piece, but I want to be all 3rd size pieces, well, how would they cut these up? And I could have them, draw it and cut it up. I'd say, how many pieces are going to be in each of these? And the idea is, well, there'd be 3 pieces. If you want to cut them into thirds, there'd be 3 pieces. So they go ahead and they do that. Okay. And now I can ask them, how many total third size pieces do we have? In other words, I want to find an improper fraction. And they could count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. I might do another problem like this just to get them used to this idea. This isn't very difficult though. At this point I might also say, let's just take a look at this here. And I'm going to use the idea of groups. And groups is multiplication. And here I see a group of 3, here I see a group of 3, and here I see a group of 3, and here I see a group of 3. I see 4 groups of 3. And when I'm thinking about that in terms of math, 4 groups of 3 is 4 times 3. So a very quick way for me to figure out how many total third size pieces I have in my groups is just look at them as groups. 4 groups of 3, or 4 times 3, which is 12, plus this one here, which would give me 13. And I could get my 13 thirds that way. Okay, so the idea of looking at these as groups and bringing in multiplication in a conceptual way makes a lot of sense, as opposed to the traditional way where you just take this, multiply it by this, and add it to that. That doesn't make a lot of sense to students. That's just an abstract routine, something to memorize. This makes sense. Okay, so now we've talked about this in terms of groups. And I could do another problem, such as 5 3/4, for example, and I could have the students show me 5 3/4. Okay, I can say, okay, how many fourth size pieces can I get from 5 3/4? So let me just kind of divide this up here. Okay, I see 3 of them there. How many can I get? Well, they could go ahead and they could break them all up on their paper, and they could cut them out, or count them up. So you have 4, 8, 12, and so on, and 20. And I can say I get 23/4. So 5 3/4 is the same as 23/4. Okay, I can ask them again, do you see groups here? And here now we see groups of fourths. I see 5 groups of 4, or 20, and 3 is 23. Now, we've generated an equivalent fraction, or I'm sorry, a mixed number to an improper fraction here, and 1 here. And I could start once they've done this idea maybe 2 or 3 times, I could start to now begin to look at this here. What they did here, could they accomplish what they did here by making the drawings and finding the groups and everything? Could they have figured it out here? In other words, here I've got 5 groups of 4. Could you have figured that out from this information that we're given right here? Or in this case, 4 groups of 3. Could you have done the same thing there? And it's not too hard for the students to say, well, yeah, there's 5 groups of 4. There's a 5 and a 4. And there's 4 and 3, 4 and 3. So maybe I could just say 5 groups of 4 is 20. So I'm going to have 20. So in those 5 holes, I'm going to have 20 fourths. And I've got these 3 right there, 23. So they could generate that algorithm of taking the whole number, multiplying it by the denominator, and adding the numerator through this type of exploration exercise. Okay? And the idea, again, I would probably emphasize, well, why do you think 5 times 4, these 5 holes, why would there be 4 parts in there, but only 3 parts here for this one? And the idea is, well, you look at that denominator, that's telling you how many parts go into a hole. But I'm letting the students tell me that. But I'm just asking a lot of questions and setting them up with different tasks where they come up with the math. They do the heavy thinking. They do the analysis and the creation. They create this method of just multiplying those 2 numbers together and adding that one to the top through my questions, through my direction. I'm facilitating. And that's really what we mean by facilitating when we teach. So that's the way we can go from a mixed number to an improper fraction. Now going the other way, it's going to be fairly similar. It's going to be this type of, this idea of exploring in terms of pictures or manipulatives, and then moving to the abstract. With the patterns we see, the things that we keep seeing over and over again. So, for example, I could have the students, maybe this time I'll use the manipulatives, and I'll ask the students, show me 11/4, and however they want to put them, they could put them as circles if they wanted. Okay, so there's 11/4, and of course I write that. There's my improper fraction, and I could say, okay, now how many whole circles can you get out of this? Because I want to make this into a mixed number. And they just take these, they can bring them together. Okay, so it looks like I get 2 whole circles. And I'm left with 3/4. And of course, that's the same amount, just looking at it in a different way. So 2 3/4. Okay. I could do another problem similar to this and collect my data on the board. For example, I could have them show me 7/3. And ask them, how many whole circles can I get out of this, because I want to write it as a mixed number. And it looks like, again, 2 with 1/3 left. Okay, and I can ask them, let's look at this now in the abstract, this writing here, because we've got 2 examples here that we generated through the concrete items. And if I'm just looking at this here, is there any way for me to look at this to know that there'd be 2 whole circles if I have 7/3? Any way I could do that? And the idea is, well, looking up here, I have 7 pieces. Every group of 3 gives me a whole, so how many sets of 3 can I get out of 7 pieces? Okay, now we're looking at 2 types of operations. We're looking at division or subtraction. I could just subtract 3 from 7, and that would leave me with 4/3, and that'd give me 1 whole, plus something else. These things really aren't equal yet. So I could take out another 3, and that's going to give me 1/3, and that's going to give, so I'm going to get 2 wholes, and I'm left with 1/3. So I can get 2 wholes from 7/3, and I'll be left with 1/3. 2 and 1/3. Okay, we could use subtraction. Okay, and for these simpler problems, maybe that's the way the students are going to want to go. Again, we could look at this one here using a different denominator and say, well, how could I have done it here? And again, we're looking for how many groups of 4, how many sets of 4 I can get out of 11. So I could subtract 4 and see if I can subtract 4 more and keep doing that. Okay? That is a valid way to solve the problem. However, I might challenge the students now to maybe if we could find a quicker way. Okay, so if I give them a problem like this, 57/4. See, if I keep subtracting 4 out from 57, it's going to take me a while to figure out how many whole circles I can get. Can I figure out another way to see how many sets of 4, how many 4s there are in 57? And the idea is, okay, yeah, certainly I could use division. So 57 divided by 4. So how many groups of 4 can I get out of 57? So I can get 14 whole circles from here. And I'd have 1 left over, 1/4 left over. And the students could draw this out to check it. Okay? But what they're doing is they're devising an abstract method based upon their conceptual understanding here. Okay? So basically what we've done now is we've introduced mixed numbers in this video. We've introduced mixed numbers and improper fractions. You're doing concrete or semi-concrete methods. Okay? Move to the abstract that way. It's very contextualized. We have the items right here. We're seeing patterns. We're seeing, oh, it works here, something works here, something works here. It seems like there's a pattern to this, that this is always going to work. And then we apply it in the abstract. We always, once we come up with this pattern, the students come up with, again, then they apply it. They apply it in the abstract, and they can check with the concrete or the semi-concrete to see, oh, well, did this really work? Like, for example, here they could see, does this really work by drawing this out? And then we're also thinking about Bloom's taxonomy. What the students are operating at are the highest levels of Bloom's. They're creating these patterns. They're analyzing a situation. They're evaluating it, finding patterns, and then evaluating those patterns too.